Okay, so as in the last video we have discussed about the hydrogen spectral series. In today's video we are going to count the number of transitions which will be made in the hydrogen spectral series. Right? Now for example, if electron coming from any shell, for example I have an electron which is present on the fourth shell. So 1, 2, 3, 4, okay, let's take 5 and 6. Okay, 6. So here we have N6, right? Here we have N6. So now an electron coming from the 6th orbit, how many transitions would be there? In how many ways it can come to the N1 orbit, right? So let's make that. Now the first possibility of that would always be it can come directly, right? It can come directly. The second possibility of this is it can come from here as well, right? Then it can come from here as well. We're gonna count the transitions. Just wait, let me make. Then it can come from the third orbit as well. It can come from the second orbit too. Second orbit too. Alright. It can come from the second orbit too. Now see, it can directly come from N6 and it can go to the N, N1. Now initially this electron can go to N5 and then it can go to N1, right? Then if I have an electron here, it can go to N4 first, then it can go to N1, right? And if I have an electron here, it can initially go to N3 and then it can go to N1, right? And if I have an electron here, it can go to N2 and then it can go to N1, right? There must be a lot of possibilities. Okay, so it can come like this as well. For example, if I have an electron here, it can go first to the N5, then it can go to the N4, then N3, then N2, and then it can go to N1. This is the possibility too, right? Initially this going N5, then it is going to N4, then it is going to N3, and then it is going to N2, and then it is going to N1, right? So this is the possibility too. Let's check other possibilities, right? For example, if I have an electron here now, right, and it is initially going to N5, then this electron from here is not going to N4, however it is going to N3, and then this electron here from N3 going directly to N1, right? Now let's count the transitions. How many transitions we have made? One is this, in which electron from N6 directly going to N1, right? Then second one is this, right? Third one is this, fourth is this, 5 is this, sixth is this, 7 is this, then 8th is this, 9th is this. Now we'll not gonna count this since we have already counted this, right? So this and this, these both are same, so we'll not gonna count this, right? We're gonna count this because this is not I can see anywhere. So 10th, 11th, right? 12th. Again, this would not be counted. This would not be counted since we have already counted this, right? So how many we have till now? 12, right? So now let's count here how many we have here. Now this again would not be counted, right? This would be counted because it is going from n5 and it is going to n3, right? This would be counted, means 13. And then again this would not be counted since this and this, these both are same, so this would not be counted, means total we have made 13 transitions. Let's check the more possibilities, right? I'm taking this color now, then I'm gonna highlight this with the yellow one. So for example, I have an electron here, then it will go to, you know what, wait, okay, it will come to this, right? And then it will not go to n3, however it will directly go to n2. Let's make these, right? 1 2 3. Let me highlight this. Now see again, this would not be counted since we have already counted this, right? This would be counted, this would be counted because we have not counted this anywhere else, right? And again the last one would not be counted because this is already we have counted here, right? So still we have 14 transitions. Let's check the more possibilities too. Okay, so suppose again if I have an electron here, right, and it is going to n5, then it is going to n suppose it is going to, wait, let me erase this. Suppose we have an electron on n5, it is going to n4 first, then it is going to n2, right? Let me connect these. It is going to n4 first, then n4, one electron is going to n2 first, and then it is going to n1. Let me highlight this too. Highlighting. Okay, so now this would not be counted since we have already counted here, right? This would not be counted too. The last one would not be counted too since we have already counted here, right? But as you can see, this one would be counted because we have not counted this anywhere, right? So this would gonna be counted. Now let's see how many total transitions we have now. 1 2 3 4 5 6 7 8 9. This would not be counted. 10 11 12. This would not be counted. Again this would not be counted, and this 13, and this would not be counted. Again this would not be counted. This 14, this would not be counted. This would not be counted. 15, and this would not be counted, right? So how many total transitions we got here? Transitions we got here are 15, right? We have total transitions gotten here is 15. Let's take example of any other one, right? For example, I have an electron on n2. Now let's take a small one, right? Now how many possibilities it has? Either that electron will be coming directly to n1, again if it will be going to n1, wait, this is n3, right? This would be going to n1 first, and this the electron which is present on the n3 shell will be going to n2 first, and then it will gonna go to n1, right? So here we have only these possibilities, right? Either the electron which is present on the n3 shell can directly go to the n1, or it can first go to n2, and then from n2 it can go to n1. So we have how many transitions here? 1 2 3. So total transitions in this case is 3. Now why to use this very big method? Why aren't we using a small method? we have formula for this as well. Let me tell you the formula. The formula for finding the transition is, wait, the formula is n2 minus n1 multiply by n2 minus n1 plus 1 divided by 2. This is the formula which we can use to determine the transitions without, making, because it is a bit complicated to make all the transitions, right? So here we have a formula. Now see, what is the n2 we have? N2 is 6, right? Because an electron is coming from the sixth shell. So 6 minus, where it is going? 1, right? N2 again 6 minus N1 is 1 and plus 1 divided by 2. Now see, 6 minus 1 is 5, right? And 6 plus 1 minus 1 cancel into 6 by 2. 5 6 are 30, 30 by 2, and when we will divide 30 by 2 we will get 15. So total transitions we will get here will be 15. So answer we have got same, right? So here is how we can make or count the transition. Making transition is a bit complicated, so my suggestion would always be to count or to calculate this by using this formula n2 minus n1, n2 minus n1 plus 1, the whole term divided by 2, right? This is the easiest one. I can count for this as well. The formula n2 minus n1, then again n2 minus n1 plus 1 upon 2. So let's check here. For example, I have a n2 here, that is equal to 3 minus, and where it is going, n1 is 1, right? Multiply by n2 minus n1 is 1 plus 1, the whole term divided by 2. Now see, 3 minus 1 is 2, multiply by, plus minus 1 cancel, 3 by 2. 3 2s are 6 by 2, and when we'll divide 6 by 2 we'll get 3. Means 3 transitions would be there, and yes, we have 3 transitions. So this is the easy way or the easiest way to calculate the transitions.